Welcome to Computer Architecture Interview Crashcasts, your go-to podcast for acing those tricky technical interviews. I'm your host, Sheila, and today we're joined by Victor, a seasoned backend engineer, to tackle a common yet crucial question. What is computer architecture? Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to explore this fundamental concept with you and our listeners.
Fantastic. So, Victor, let's start with the basics. How would you define computer architecture to someone in a phone screen interview?
Great question, Sheila. Think of computer architecture as the blueprint for a computer system. It's all about how we design and organize the different parts to work together smoothly. This includes the physical components, or hardware, and the rules that govern how they interact to process information and carry out tasks.
That's a solid starting point, Victor. Could you break down some of the key components that make up computer architecture?
Certainly, there are three main components to keep in mind. First, we have the processor, or CPU, which is like the brain of the computer. It's responsible for executing instructions and performing calculations. Second, there's the memory, which stores data and instructions, both for short-term and long-term use. And third, we have the input-output systems, or I/O for short. These handle communication between the computer and the outside world, like keyboards, screens, or networks.
Excellent. Now, let's dig a bit deeper. Can you explain what an instruction set architecture, or ISA, is, and why it's important in computer architecture?
Of course, the instruction set. Architecture, or ISA, is like a computer's language. It defines the set of instructions that a processor can understand and execute. Think of it as a bridge between the hardware and software. The ISA specifies things like operation codes, data types, and how the processor should handle memory. Popular ISAs include x86 for most personal computers and ARM for mobile devices. The choice of ISA is crucial because it affects the computer's performance, power efficiency, and what software it can run.
That's a great explanation, Victor. Let's move on to memory. Can you discuss the concept of memory hierarchy and how it relates to computer architecture?
Absolutely. Memory hierarchy is a key principle in computer architecture that addresses the balance between speed and capacity. Imagine it as a pyramid, with faster but smaller memory at the top, and larger but slower memory at the bottom. Typically, this hierarchy includes 1. Registers, which are the fastest but smallest, 2. Cache, which comes in levels like L1, L2, and L3, 3. Main memory, which is your RAM, 4, and finally, secondary storage, like SSDs or HDDs. The goal is to create the illusion of a large, fast memory system by keeping frequently used data in the faster levels.
Excellent breakdown. Now, let's talk about improving processor performance. Can you explain the concepts of pipelining and parallelism in computer architecture?
Certainly. Pipelining and parallelism are techniques used to boost processor performance. Pipelining is like an assembly line for instructions. We break down the execution process into stages, allowing multiple instructions to be processed simultaneously at different stages. This increases efficiency and throughput. Parallelism takes this idea even further by allowing multiple instructions to be executed at the same time. There are a few ways to achieve this. 1. Instruction-level parallelism, or ILP, which executes multiple instructions in parallel within a single processor. 2. Thread-level parallelism, which runs multiple threads concurrently. 3. And data-level parallelism, which performs the same operation on multiple data points simultaneously, often used in specialized processors like GPUs. These techniques have led to advancements like multi-core CPUs and powerful graphics processors, which are key features of modern computer architecture.
That's a comprehensive explanation, Victor. Now, let's consider an edge case. How does quantum computing fit into our understanding of computer architecture?
That's an intriguing question, Sheila. Quantum computing is like stepping into a whole new world of computer architecture. Unlike traditional computers that use bits, the ones and zeros, quantum computers use something called qubits. These qubits can exist in multiple states at once, thanks to a principle called superposition. The architecture of a quantum computer is fundamentally different. Instead of the logic gates we're used to, it uses quantum gates to manipulate qubits. The memory and processing units are unique too, often needing extreme cooling to maintain these delicate quantum states. While quantum computing doesn't replace classical architecture, it opens up new possibilities for solving certain complex problems much faster than we ever thought possible. However, it also brings new challenges in areas like error correction and keeping qubits stable. Understanding quantum computing architecture is becoming increasingly important. It could revolutionize fields like cryptography, drug discovery, and simulating complex systems.
That's fascinating, Victor. As we wrap up, what advice would you give to candidates preparing for computer architecture questions in interviews?
Great question, Sheila. I'd recommend the following. 1. Start with the fundamentals. Make sure you have a solid grasp of basic components and how they interact. 2. Stay updated. Computer architecture is evolving rapidly, so keep an eye on current trends and technologies. 3. Think about trade-offs. Many architecture decisions involve balancing factors like performance, power efficiency, and cost. Be prepared to discuss these trade-offs. 4. Practice explaining complex concepts simply. This shows deep understanding and good communication skills. 5. Relate to real-world applications. Try to connect architectural concepts to practical systems you've worked with. 6. Be ready to go deep. While starting with basics is important, be prepared to dive into specifics of topics like cache coherence or branch prediction if asked.
Excellent advice, Victor. Thank you for sharing your insights with us today. To our listeners, remember that understanding computer architecture is crucial for back-end engineers, as it underpins many system design and optimization decisions. Practice articulating these concepts clearly, and you'll be well prepared for your interviews. Until next time, this is Sheila, signing off from Computer Architecture Interview, Crashcasts.